Hey, how you doing? How are we? Okay, this is going to be about how Inertia debunks 106-year out-of-date pseudo claim. Um, I think we all know what that claim is. It's a claim of a force of gravity. I'm going to focus on a particular thing here. It will become evident what that is. Okay, I have a bit of reading to do. I have some diagrams and different things. I'm going to try and make it as fast as possible. Let's get stuck into this. Okay. Inertia debunks 106-year out-of-date pseudo claims. There is a claim by certain people that Einstein was incorrect and that gravity is actually a force of attraction between masses and not a 4D effect, as claimed by Einstein in his theory of general relativity model, colloquial. These people claim that that gas is being controlled primarily by a downward bias as gas is claimed by these people to be getting pulled down towards the Earth's surface by this force of attraction between masses. Question mark. So we must start at the start with the question of what is mass. Okay, mass in physics, quantitative measure of inertia, a fundamental property of all matter. It is in effect the resistance that a body of matter offers to a change in its speed or position upon the application of a force. The greater the mass of a body, the smaller the change produced by an applied force. Mass is defined in physics as inertia. So what is inertia then? A tendency to do nothing or to remain unchanged. In physics, a property of matter that by which it continues in its existing state, like above, or of rest, or uniform motion in a straight line unless that state is changed by an external force. So does gas have inertia? Well, according to physics, all matter is affected by or has inertia, but this is a little difficult to reconcile with when it comes to gas, as gas is not like other matter. Solids are many tiny parts that are compressed together with tight ungiving bonds, and liquids are also bonded, but not as tightly as solids, so they are more pliable and can take to any shape. But gas is a collection of tiny intramolecularly bonded atoms that are not connected to each other in any way, shape, or form. All solids and liquids have intermolecular bonds, so all of their individual tiny parts stay together as a whole. But gas is the state of matter where all these tiny parts begin to act independently of each other in their general movements. Here is a visual of these states of matter. Okay, you have the diamond here showing the solid. So solids are tightly bonded together. There is no movement. They can vibrate. They are supposedly vibrating. I don't know, but there is basically no movement going on, as with the diamond here is the example of. Liquids are bonded together also, but not as tightly. You could think of the hydrogen bonds between them as little chains, and they all move about. They all move about, but not independently of each other. They can just move, but they're still stuck as a whole. As you can see, liquids are contained on the sides and at the bottom, just like with this glass of orange juice up here, as they have to be. Okay, then on the gas, as you can see, each one of these molecules or atoms move about on its own. It is independent of all the other ones. There is nothing connecting any of them, and because they constantly move about and collide off of each other and off of the walls of a container, to keep them in a space, you must keep them totally contained at the bottom, top, and at the sides. Then you have plasma. Plasma moves about like gas, but it has charged particles, pluses and minuses, so positives and negatives. Plasma can be held in place by a magnetic field, a toroidal field, but without something like that, you would need a constant full container where all sides are containing the plasma to hold it. But normally it's too hot for plasmas, are normally, except for maybe some plasmas are too hot for to be contained, like hydrogen plasma, by a solid container. But you have other plasmas that are in neon signs, like up here, that can be contained in that way. So, four states: solid, liquid, gas, plasma. So, solids are bonded tightly, liquids are bonded loosely, gas is not bonded at all, and plasma is not bonded either. So, what would be the easiest way to describe each state and its characteristics? Solids are unmoving and have a linear downward weight, so solids do not need to be contained, as they are the containment for other states. Liquids are more pliable and do move, but also, like solids, have a linear downward weight and need to be contained on all sides and underneath. As although their weight vector is naturally down, they can leave their container due to a rise in temperature, causing them to evaporate once they have transitioned into a gas. Gases constantly move about in all possible directions and must be contained on all sides, as they are only controlled by temperature. They cannot be manipulated by any other means or forces, with the exception of a container size change, which will change the pressure of the gas, as a smaller container will raise pressure and a larger container will drop pressure once the gas amount stays equal. Gas will, under normal room temperatures, escape any container that is not closed on all sides and at top and bottom, with the possible exception of the more dense gases, where the escape velocity will be slower as they are closer in density to liquids, but they will still behave as a gas and escape eventually as they are unbonded. Gases will always try to fill every available volume. Gas will always seek to fill any location that is of a lower pressure than the location it occupies, as it will constantly seek to equalize the pressure and will only be stopped from doing this by a change in temperature. Gas atoms will always move independently of other atoms. Plasmas are ionized gas, so they will still behave as gases, but with one main difference: the plasma atoms are positively and negatively charged. So plasmas can be held in place by an electromagnetic field, so they don't need to be contained on all sides and top and bottom in the presence of a toroidal field. Plasma atoms still move about independent of each other. So let's look at the definition of inertia again. Inertia: a tendency to do nothing or to remain unchanged. A property of matter by which it continues in its existing state of rest or uniform motion in a straight line, unless that state is changed by an external force. Inertia: a property of matter by which it remains at rest or in uniform motion in the same straight line unless acted upon by some external force. An analogous property of other physical quantities, such as electricity. To indisposition to motion, exertion, or change, right? Inertness, right? Inertia. In physics, inertia is the resistance of any physical object to any change in its velocity. This includes changes to the object's speed or direction of motion. An aspect of this property is the tendency of objects to keep moving in a straight line at a constant speed when no forces act upon them. It's from Wikipedia. So inertia could best be described as basically a resistance to change from a position or change from a vector path and velocity. So something that sits still and motionless, or something that keeps a constant rate of motion and direction in a straight line. So the claim of two masses being attracted to each other due to a force of no origin that was superseded in 1915 by Albert Einstein must be false. The reason I say this is simple. Look at this diagram. Now, in an idealized world, gas could be described as exhibiting inertia, but it would be always only fleeting inertia, even by basic description, if gas could even be described this way at all. You see, the claim of one mass being attracted to another mass is contradictory in a sense, as worded differently, one could describe it as inertia being attracted to inertia due to a force of attraction of undefined origin. Put more simply, it is a resistance to change being attracted to a resistance to change due to a force of no origin. When spoken about in those terms, is it any wonder that Albert Einstein threw this rubbish out the window, as it is nonsensical, contradictory babble? Now we must tackle the claim that gas molecules are being pulled downward towards the ground by a force of no origin. gas filling an available volume will either fill it via diffusion or effusion. Diffusion versus effusion. Diffusion, net passive movement of particles, atoms, ions, or molecules from a region in which they are in higher concentration to regions of lower concentration. Occurs in solid, liquid, and gas molecules. Molecules move freely throughout space. Concentration gradient is the driving force. Collisions occur among the molecules, a less efficient method. Effusion, movement of gas particles through a small hole, occurs only in gas molecules. Movement of molecules occurs through tiny holes. Concentration gradient of gases generates a pressure gradient. There is no collision among the molecules, more efficient due to the pressure difference involved. Just want to state that gas experiencing effusion moves faster than gas experiencing diffusion. So if people want to think back to a particular little hole that was in a supposed spacecraft a couple of years ago, and think about effusion and look into effusion, and that should change your mind if you're honest. So either way, gas will always escape from its current container to another volume of lesser pressure if there is an available escape route, and it will not and cannot be held back by any means other than temperature. And to have temperature, you need containment. Both temperature and pressure require containment, with the supposed exception of radiative heat. But even at that, radiative heat can only affect something that is contained, whether it be inside a person's body or within a container of a different means, as temperature cannot rise or fall in nothing. So to raise the pressure of a gas that holds a constant volume, you need to raise the temperature, and inversely, to lower the pressure of a gas that holds a constant volume, you need to lower the temperature. Heat will cause more motion, cold will cause less motion. Temperature and gas calculations. Temperature can be measured using the Celsius and Kelvin scales. Gas pressure increases with temperature. Equations explain the relationship between pressure, temperature, and volume in gases. Part of physics, single science, solids, liquids, and gases. Temperature and pressure calculations. When a gas is trapped inside a container which has a fixed size, its volume cannot change, and the gas is heated, the particles will gain kinetic energy, which will make them move faster. The temperature of the gas is proportional to the average kinetic energy of its molecules. Faster moving particles will collide with the container walls more frequently and with greater force. This causes the force on the walls of the container to increase, and so the pressure increases. If the temperature of the gas is measured on the Kelvin scale, the pressure is proportional to the temperature. So we are all in agreement. Temperature controls the amount of movement and also the basic density of gas. Warm, less dense air flows upward, and cold, more dense air flows downward. And in our world, we have a temperature gradient that's warm at sea level and cools off in a gradient as you rise towards the bottom of the stratus plane. If people want to know more about this pressure gradient, please refer to my presentation on how the sun causes our gas pressure gradient. But in this presentation, I want to focus on the claim that there is a force of no origin pulling gas downward. You see, the biggest problem for this idiotic claim is found in the very basics of the claim. 1. Mass is inertia, and inertia is resistance to change. So when do two resisting entities become attracted to one another? 2. Gas is unbonded, so this means that each molecule is a separate entity. So to calculate gas as anything but very small single separate entities is wrong, as you're essentially denying gas behavior and what allows it to happen, as gases can't behave as gases if they are not gases, and to be gases they must be an accumulation of single entities and must be treated as such. Right? Question mark. 3. We must refer to this diagram again. This is the diagram again, where it shows all the gas atoms flying in all directions. As this diagram shows, there is no attractive force of no origin in gas behavior, as gas behavior is dictated by a repellent force that is demonstrable and isolatable, and not an attractive force of any kind. 4. Building on the previous point, this ridiculous gravitational force of attraction between inertias that was superseded by Albert Einstein's theory of general relativity in 1915, relies on a very simple premise, and that is that a smaller mass will be attracted to a larger mass, as the larger the mass, inertia, will have more gravitational attraction. But every gas molecule is a single mass in that belief. So why are all these little gas molecules slash atoms moving about independently of everything else without exception and not stuck to the Earth's surface? Question mark. 5. If a gas atom is described as having inertia, then how is that possible when gas rate is a calculation that states that gas atoms move about at a speed of 500 to 750 meters per second? Which means that at any time a gas atom can move from one temperature to another in under a second. And this then also means that that gas atom will undergo a change in velocity. And if it hits 1,000 other gas atoms within that second, then that could be 1,000 velocity changes within just that second. But that is not the description of inertia, is it? If inertia is a resistance to a change, then the natural behavior of gas debunks the claim that gas can have inertia, as a gas atom's primary natural makeup is to not resist change, but rather embrace change by not staying still and not losing any gained kinetic energy through collisions and other gas atoms. Not staying still and not losing any gained kinetic energy through collisions with other gas atoms or surfaces, container walls or otherwise. Gas atoms do not behave like an entity undergoing inertia because they are not experiencing inertia. They are experiencing the opposite from inertia, as they are designed to embrace a constant change. I'm just going to read that again because I messed it up. If inertia is a resistance to a change, then the natural behavior of gas debunks the claim that gas can have inertia, as a gas atom's primary natural makeup is to not resist change, but rather embrace change by not staying still and not losing any gained kinetic energy through collisions with other gas atoms or surfaces, container walls or otherwise. Gas atoms do not behave like an entity undergoing inertia because they are not experiencing inertia. They are experiencing the opposite from inertia, as they are designed to embrace a constant change. 6. Gas atoms move about independently of all other outside entities and never hold any particular vector, but instead embrace and experience all vectors in all and every possible direction. So if these tiny gas atoms don't experience inertia and are not confined to a life stuck to the surface of the Earth, and each gas atom is an independent entity, then there is no attractive force of mysterious origin, as if there was, gas behavior would cease to exist immediately. 7. Gas density and gas movement are both dictated primarily by temperature, and any gradient of gas atoms that we experience in our world is not due to a force of no origin, but rather the constant relationship between temperature and its direct and natural effect on gas atoms. As temperature causes convection towers and temperature boundary layers, so in a nutshell, every gas effect we observe in our world is caused by temperature and not a force of no origin. That got debunked by Albert Einstein in 1915, the end. And just to add at the end, I don't believe in Albert Einstein's theory of general relativity, but I know that it debunked and superseded all claims and descriptions of gravity previous to that, as Albert Einstein wasn't so stupid to believe that there was a force of attraction between masses, and neither was Isaac Newton. There were some other people in between them that thought that was possible, but those two individuals, Isaac Newton and Albert Einstein, did not believe that nonsense, and they would never have believed it. And that's why it was debunked and thrown out in 1915. And if you want to know why it's still being taught in schools and colleges, look at my video where my two or three videos back from this one where I give that explanation. Okay, thanks for watching.